power flurries through the air into the ground. My soul is spiraling in frozen fractals all around. And one thought crystallizes like an icy blast.
So I gotta be honest, there was probably a point in time where I was completely obsessed with that song. And, well, actually, I probably still am a little bit because every time I hear it in the car, I just need to sing it to the top of my lungs. But just want to let you guys know, I don't know if you really pay attention to the lyrics, but there's a point in that song that I tried to highlight in the clip where she mentions the word fractals. And I don't know if you ever heard of fractals before. They are the little patterns that snowflakes have, and a bunch of other things in nature actually have patterns of fractals. But the idea of a fractal brings into play complex numbers that we've been talking about, and I tried to highlight that here. Fractals are infinitely complex patterns that repeat a simple process over and over and over in an ongoing feedback loop. And it kind of brings into the play if the cyclic cycle that you guys might remember from the last video, how the I and I squared and I to the third, okay, these all followed a cyclic pattern where it goes through and through and through. That's exactly what fractals are. It's the same pattern repeating itself over and over and over and over again. And you can kind of see that here, how we have this swirl going on in this case, but we have the same swirl probably going on in this one over here, and even the same swirl going on in here, and maybe even there. So fractals are just the same pattern repeating itself over and over and over again. Now that we kind of have an idea about what a complex number is, okay, we talked about that in the last video where we have a real part and we have an imaginary part, we're going to talk about how we can add, subtract, multiply, and divide these complex numbers in this video lesson. So we're going to tackle adding and subtracting first. Okay, these are going to be pretty simple, not going to lie, they're going to be really easy. And these are as easy as just combining the reals and then combining the imaginaries. So almost like combining like terms, we want to keep everything kind of separate. So combine the reals and then combine the imaginaries, and finally we're just going to put them all together. So if we take a look at our first one, let's combine the real parts first. So if we look at our first complex number, my real part would be 4, because that's the number that does not have the I. And in this particular case, I want to add this complex number to it, but the real part in this complex number would be the 7. So if I take this real 4 plus this real 7, I would get an overall real of 11. Next, let's try the imaginaries. Okay, abbreviate maybe a little bit. This negative 3i would be the imaginary from the first complex number, and I specifically want to add it to this imaginary from the other one. So positive 9i. And if I take negative 3i plus 9i, combining like terms, that would give us 6i. Okay, so we added the reals, added the imaginaries. All we got to do is combine our new parts, or our new answers. So my new complex number would be the real 11 and the positive 6i. Okay, that's simple. Adding the reals, adding the imaginaries, and then combining them together to get your final answer. If we try this one, this time we're actually subtracting, so we got to be a little careful. We're going to take the real part. Okay, that's an E. So the real from our first complex number would be 5, and we're going to subtract it from the real of our second complex number. That'd be 3. 5 minus 3 would give us an overall real of 2. If we take a look at the imaginaries, we'd have come on, pen. We'd have negative 2i, that's the imaginary, and we're going to subtract the 7i. So overall, imaginary negative 2 minus 7 would give us negative 9, but we got to put these parts together. So we'd have a real of 2 and then an imaginary of negative 9i. Sorry these keep looking like J's, okay, it's my pen, kind of weird. If we check out the last one, this one can be kind of tricky. We're going to keep the reals and the imaginaries separate, just like terms. We're going to combine everything that matches. If you think about this, obviously this is an imaginary number. Okay, it has the I attached to it, but we don't have a real part. So you can imagine that there's a 0 going on right here. So I'm going to take the real 0 from my first complex, and in this case I'm adding. So let's add the real from the other. So that would give us 5. Now the imaginary, we'd have the 4i, and we're going to add the negative 12i. So if I have 4 and I'm adding a negative 12, okay, this is the same thing as actually subtracting. You don't get confused if you see two operations. If you have a positive and a negative overall, that would give you a negative. So 4i minus 12i would give us a negative 8i. So let's combine those together. My real part is 5, and my imaginary is negative 8i. That's simple, guys. Just like terms. Keep the reals together, keep the imaginaries together. Let it go, let it go. Oh, we're back. Sorry. Now that adding and subtracting was so simple, let's talk about multiplying. Normally when we see parentheses, okay, just like everyone wants to do, we think about distribution. Okay, so let's do that in this case. 4 times 3 would give us 12. 4 times 5 would give us 20. Remember, this 5 was an imaginary, so we can't forget that I. That one is a piece of cake. Let's try distributing in an imaginary number this time. Okay, the last one we did, 4 was a real number that we distributed in. Let's take a look at an imaginary. So 2 times 3 can give me 6, but I still have the I. And then if I do another distribution, 2 times 7 would give us 14. But if I take I and distribute it into this I times I would give us I squared. Okay, so let's talk about how we can take this just a little bit further. There really isn't anything we can do with 6i. Okay, nothing there. But if you remember from the cyclic cycle, okay, from the last video, we had this pattern kind of happen where, oh, we know I to the first is just I, but the moment we had I squared, notice how it was able to be simplified or reduced to a real number. Okay, negative 1 is a real number. It's on a number line. It's on a graph. So what we can do is kind of use this to our advantage in this case. I squared I have right here in my problem, but notice how I squared is equal to negative 1. So instead of writing I squared, I can simply replace it with a negative 1, because notice how they mean the exact same thing. Okay, they're equal to each other. With this replacement, we can take this a little bit further. We can take positive 14 times negative 1, which would give us a negative 14, but let's write this as a complex number where the real number goes first and then the imaginary number comes second. So our real in this case would be negative 14. Okay, that doesn't have an I attached to it, but the imaginary, the 6 over here does, and it happens to be positive. So we'll say plus 6i. So just a little bit of rearranging. Okay, now the big idea in this case, okay, right here, I squared. Okay, we're going to rewrite, whenever we see I squared, we're going to rewrite it as a negative 1, because according to this cyclic cycle we saw before, I squared is equal to negative 1. Okay, so whenever you see I squared, okay, little stars, fireworks should be going off in your head, we can rewrite it. Let's try one that's just a little bit more difficult. Okay, we're going to take this complex number and multiply it by this one. And hopefully light bulbs kind of go off when we see these two parenthesis groups next to each other. We need to think about double distribution. So let's just first bring in the 3. 3 times 3 would give us 9, and then 3 times 7 would give us 21, but since I had an I with the 7, okay, it stays there. So there's our first distribution. Now we got to distribute in the negative 2i, okay, that imaginary number. Negative 2 times 3 gives us negative 6, but again, we had the I, we can't forget about that. Negative 2 times 7 gives us negative 14, but I times I gives us I squared. And we have light bulbs, we have fireworks going off right here. Okay, we have an I squared. Let's rewrite it. So we have 9 plus 21i minus 6i minus 14, and we're going to rewrite I squared as negative 1. But if I can rewrite it as negative 1, let's actually simplify it. Negative 14 times negative 1 gives us a positive 14. right, so now take a look at this. We have a real number right here and another real number right there. Okay, those are like terms. Those are real numbers. Let's add them together. Combine like terms, we have 9 plus 14, which can give us 23. But then if I take a look here, I have an imaginary number and another imaginary number. Those are like terms. 21 minus 6 can give us a positive 15. And we can keep the imaginary I because those were our like terms. All right, so another instance in this case where knowing that I squared was -1 is going to help us simplify it just a little bit further. Again, notice how this is a complex number and we're multiplying it by another complex number. So it kind of makes sense that our overall answer is a complex number. We have a real part and we have an imaginary part. All right, so before we get too far ahead of ourselves in trying to tackle division of complex numbers, I want you to try adding and subtracting and multiplying some on your own. Pause the video and see how you do. All right, so let's check out and see how we did. First one, we were adding complex numbers together, so keep our reals and imaginaries separate. We have the real 2 plus the real 7, which gives us a real 9, and then the imaginary 5i plus the imaginary negative, you can think about this as -1i, which would give us a total of -6i. So if I combine my reals and imaginaries back together as a complex number, we would have the positive 9 and the minus or subtracting 6i. If we check out subtraction, reals with imaginaries again, 3 minus 5 would give us a -2 of a real number. And then the imaginaries, this is where hopefully we didn't get really tripped up, 7i minus -2i. So it really might help some of you out if you actually want to write it like that, because the moment I see double negative, I know that can change to a positive. So we took the 7i and we are subtracting the -2i, which would actually change it to a +2i. So 7 and 2 would give us 9. So again, real of -2, imaginary of a positive 9i, we can put those together. Let's check and see how you did on the multiplication. So we have some distribution going on. Did this get ya? Okay, light bulb go off. I squared, we need to simplify or rewrite it as a -1. Okay, so hopefully you did your distribution correctly. Make sure you write it as a complex number. Okay, the real part always goes first and the imaginary comes second. Our last one, kind of a doozy. Okay, we had that double distribution. Okay, really make sure how you're multiplying those correctly. Another light bulb should go off right here. I squared, we can rewrite it as -1. So if I combine my reals, I get 23, and combine my imaginaries, I would get -7. Hopefully we done good. All right, so now that we're masters about adding, subtracting, and multiplying, let's try to tackle some division. All right, so when we see a fraction kind of like this, 4 minus 3i, obviously we know that's a complex number, and we are dividing it by just one number. So whenever you're dividing by one item, you got to think about dividing the 2 or 3 or 4, however many parts you have up top, dividing those separately. So if I think about the real 4 divided by 3, can't really simplify that, so we can keep that as 4 over 3. But we can also rewrite this side as well. We are subtracting, and we have a 3i over our denominator of 3. So what you can think about doing is breaking apart one fraction and making it two separate ones. Because when you do that, notice how even though this one doesn't simplify, okay, we still have 4 over 3, we can cancel out these 3's over here, which we would in this case just be left with I. Okay, so here's another complex number. We have our real part, okay, 4/3, that's an actual number, but we have our imaginary over here because we have, if you want to think about it as -1, you can. So whenever you just have one item or one number on the bottom of a fraction, you can break apart the top into two separate parts. Let's try to tackle some equations. Okay, we're going to try to figure out what x is. So if I think about working from the outside in, getting rid of a power of 2 might be a good first step, which means we can divide, or not dividing, we can square root both sides. So square root and 2 cancel. We're just left with 2x plus 1. And since I took the square root of both sides, I cannot forget about that plus or minus. Okay, that's going to come into play a little bit later. So let's simplify our right-hand side. We have plus or minus. The square root of 9 is a whole number 3, but since my inside was negative, okay, can't forget that imaginary I. Alright, so just like before, trying to figure out what x is, right now it's kind of easy. We can subtract 1 from both sides. So I'm left with 2x equals. Now we really got to be careful. This negative 1 is a real number, so that comes first. But the 3i is an imaginary. Okay, see that I there kind of clues you into that. So the plus or minus 3i would have to come second. Okay, here's a complex number. We have a real part and we have an imaginary. Our last step is where this division comes into play. We're going to have to divide both sides by 2. So those can go away, and we're just left with x. Now take a quick second. Notice how my right-hand side over here kind of looks like the first one we did. I'm dividing by one number on the bottom, so that means I can break apart the top into 2 separate pieces. So we can take negative 1 divided by 2. All right, so negative 1 divided by 2. I have my plus or minus sign. And then my second part, we have 3i over 2. Alright, so just like that, notice how we can't simplify 1 over 2 or 3 over 2. Okay, in this case we could. In our first example, we could cancel out the 3's, but there really isn't much here that we can do, so we'll leave it just like that. Here's our real number, and then here's our imaginary number. Let's try one that's a little bit more involved. Trying to solve for y, work from the outside in, so maybe subtract 1. We're left with 3y minus 1 squared. And I get negative 27. Now this one looks just like what we had in our second example. So let's get rid of the power of 2 by taking a square root. Okay, so those cancel. And I'm left with 3y minus 1. Since I took a square root, can't forget the plus or minus. Alright, so maybe we can simplify the right-hand side a little bit. We can break apart 27 into a 9 and a 3. Okay, square root those. Square root of 9 is a whole 3. And since my original number was negative, I need the I. And my other part over here is the square root of 3. Okay, so kind of getting a little jumbled in here. Okay, kind of close together. Really make sure you know where's that coming from. So I break apart 27 into a perfect square. So square root of 9 is 3. My original number was negative, so I need the I, and the square root of 3 is left over. So now, really easy steps. We're going to add 1. And here's my complex number. Here's a real number plus 1, positive 1, that comes first. And then my imaginary part, what I have right here, the 3i square root of 3, comes second. So there's complex, a real and imaginary. The division by 3 comes in next. So one number on the bottom, I can break apart the tops. 1 over 3 plus or minus. And then we have 3i square root of 3 over 3. Now hopefully you look at this and think, well, maybe we can take this one step further. We can't really simplify 1/3, so that'll stay the same. But notice how this is an outside 3 being divided by another outside 3. So those cancel. Okay, we can't simplify the square root of 3 because that's on the inside of a radical. Okay, this outside 3 can be divided by another outside 3. So those cancel. All we're left with is the I square root of 3. So, I mean, sometimes you'll be able to simplify them like we did this one and we did the first one. Sometimes you might not, okay, like our middle one was. It just depends on what problems you're dealing with. Alright, so one more thing about division. We're going to talk about conjugates, and hopefully some of you remember how when we talked about square roots, we cannot have a radical in the denominator, okay, in the bottom of a fraction. Same thing kind of going on with these imaginary numbers. I do not want any i's, no imaginary numbers, left in the denominator. So we're going to be a little tricky, just like we were with square roots, on how we get rid of them. And we're going to use something called a conjugate. Okay, now a conjugate, when we're specifically looking at the denominator, we're going to change the sign in the middle of the two terms. So we're going to change the sign in the middle. Okay, normally we have an imaginary number, maybe a plus, okay, and then the imaginary, okay, those are complexes, or a complex number. If we change the sign in the middle, a plus, would change to a minus. Okay, so that's how easy it is. A complex, you're keeping the numbers the same, you're just changing the sign in the middle of them. Okay, so we have to erase that though. I need some room here. So we do not want a 2i in the denominator. Now, since this is only an imaginary number, you can think about the real as 0 plus 2i. So if we're going to change the sign in the middle, notice how the sign right now is a positive. Okay, we're going to change that to a negative. And just like how we multiplied radicals on the top and the bottom, we're going to multiply our denominator on the top and the bottom. So we're going to take 2i, which is our denominator, and notice how we change the sign. Okay, that's the conjugate part. And we're going to multiply that on top as well. Okay, so we have one fraction times another fraction. We know we can multiply fractions by going straight across. But we got to be careful here because notice how we have more than one item in the top of this fraction. We almost have to think about distributing this one imaginary number into the other parts. So if I take negative 2i times 4, I get negative 8i. And then negative 2i times negative 3i would give me a positive 6i squared. Now in the denominator, 2 times negative 2 would give me negative 4, and I times I would give me I squared. Okay, now here's a light bulb hopefully going off. We have I squareds going on, so we can rewrite those. We know we can rewrite I squared as negative 1. Alrighty, not too bad. So we would get 6 times negative 1, which is negative 6, and then negative 4 times negative 1, which is just a positive 4. And notice again here, we have one item in the bottom, so we can probably break apart and simplify the two separate pieces. Let's maybe works over here. We can take negative 8i divided by 4, and then we are subtracting a 6 over 4. Now negative 8 divided by 4 can give us negative 2i, and then the 6 over 4 can simplify to 3 over 2. But remember, we want a complex number, and the real part always comes first. So here's my real part. Okay, there's no I with it, negative 3 over 2. And then my imaginary with the I would have to come second. Okay, just a little rearranging, putting the numbers in the correct order. Okay, so look at how this, our conjugate, we just switch the sign. Instead of a positive, we just have a negative, and we're going to multiply the top and the bottom of this fraction by our denominator, just like we did with radicals, because that's what we're trying to get rid of. Okay, we don't want i's in the denominator. All right, so maybe, hopefully, I have enough room over here for the second one. Maybe block this off a little bit. Let's try to find the conjugate of this one. Okay, 3 plus 2i. My conjugate, if I just change the sign in the middle, would be 3 minus 2i. Okay, that's how simple it is. You just change the sign in the middle. But if you're going to multiply by 3 minus 2i in the denominator, we got to do that up top as well. Now here's where it's going to get good. We have this whole top times this whole top, and then this whole bottom times this whole bottom. So we're going to have a bunch of distribution going on here. We're going to take 4 times 3, so there's our first swoosh, we get 12. 4 times negative 2i, which would give us negative 8i. And then we got to bring in the other imaginary number. So negative 3i times 3 would give us negative 9i. Negative 3i times negative 2i gives us positive 6i squared. Okay, so that's just the numerator. We got to do the same thing on the denominator. 3 times 3, my first swoosh, if you can imagine that, would give me 9. 3 times negative 2 would give me negative 6, but I still have the I there. Now, our second swoosh, we can bring in or distribute in the 2i to the 3, which would give me a positive 6i. And then 2i times negative 2i would give us a negative 4i squared. All right, so light bulbs, again, I squareds, we can change those to negative 1s. Maybe I'll combine some like terms first, kind of make it simple, maybe take up less room here. Right here in the middle, notice how I have some like terms. Okay, negative 8i and negative 9i. Together, that can give me negative 17i. Maybe I'll combine some like terms right off the bat. I still have the 12 out front, and I can rewrite I squared as negative 1. So I kind of did a lot right there. You might need to maybe rewind and go back just to make sure you catch that. I'm going to do the same thing on the bottom as well. Notice how in the middle I kind of have some like terms, but -6 and +6, they cancel each other out. So I really don't have any more i's left in the bottom, or at least in this part. I can keep the 9, and I have -4, but I can rewrite I squared as -1. So notice how I don't have any more imaginary numbers in the denominator. That's what we're trying to do here. We're trying to get rid of those i's in the denominator. Let's clean it up a little bit. Let's see, 12 minus 17i. 6 times -1 can give me -6. On the bottom, I have 9, and then -4 times -1 is a +4. Combine some like terms up top. 12 minus 6 can give me 6, and I have a minus 17i. In the denominator, 9 plus 4 can give me, oh wow, 13. There we go. And then again, notice how we have one number in the denominator. We can break apart the tops. So hopefully I can fit this in here. We can have 6 over 13. Okay, so that's my first part. But then we are subtracting, so we'll put that there. In my second part, I would have 17i over 13. Okay, that's a 3. So there's our complex number. We have our real part comes first and our imaginary comes second. And again, just like multiplication, it kind of makes sense. If we take this complex number and divide it by this complex number, it makes sense that we should have a complex number as our answer. So that's why we want to break it apart like this instead of leaving it as one big fraction. We like to break it apart. That way we can see the real part and the imaginary part as separates. All right, so we just tackled division. I want you to pause the video and try some on your own. The top two are equations. I want you to figure out what is x, what is y, and then the bottom two are these conjugates where you got to switch that sign in the middle, okay, in between the real part and the imaginary part, and make sure you multiply on top and the bottom. So pause the video and see how you do. Alrighty, let's check our work and see how we did. I only put the solutions in the little boxes for each problem. I did show some of my work in the bottom two. I showed you what the conjugate should look like if you multiply on top and the bottom when you switch that sign. So check your work, see how you did. If you did not get these same answers, okay, that's okay. I don't expect you guys to get this after the first try or even after the first time you interact with this video lesson, okay? So if you didn't get these, that's completely alright. I just want you to try your best and really make sure that you ask me for help next time I see you in class. I'd be more than willing and more than happy to help you with some of these, okay, and I'll check your work and help you through it. All right, so I will see you in class next time. See ya.